Hello dear students, welcome to the class. So we are discussing the chapter wireless communication. In the wireless communication we have studied the block diagram, basic block diagram of communication system, the electronic communication system. Okay, and we have also studied many other concepts. We have studied the EM waves. We have studied about the EM waves, where we have studied the radio waves, many concepts of the EM wave, otherwise the characters, otherwise the features of the EM waves we have studied. Where we have seen that EM waves are basically electromagnetic waves that will be having electric as well as magnetic field. So EM waves are basically having both fields, electric and magnetic fields. So apart from the EM waves, we have also seen the types of waves present in the radio wave communication. The types of waves. The types of waves are ground waves, ground reflected waves, space waves, and sky waves. So the ground waves are the types of waves, otherwise the type of radiation that follow the surface of the earth to reach the receiver from the transmitter. So while propagating from the transmitter to receiver, they follow the path of the surface of earth. Such signals, otherwise such waves are called as what? Ground wave propagation, otherwise ground waves. Next, the ground reflected waves. In the previous class also I have told you, the signal transmitted from the transmitting antenna strikes, otherwise hits the earth, otherwise surface of earth, reflects and reaches the receiver. Okay, so from the source to the destination, the signal gets reflected once and reaches. Such type of waves are called as what? The ground reflected waves, right? Then we have studied about the space waves. Space waves are also called as the line of sight waves, otherwise they require the condition of line of sight to be considered there. Okay, that means the line of sight means what? There should be direct link established between the transmitter and receiver. They should be placed face to face and there should be no obstacles in between. Such type of waves are called as what? The line of sight waves, otherwise the space waves. Okay, so in this case the communication takes place through the troposphere. Okay, the immediate layer of the above the earth called as the troposphere. So the communication takes place through the troposphere here, and for the better operation, otherwise the better communication through the space waves, it is always preferred for the antennas, that is the transmitting and receiving antennas, to be placed at some height. Okay, to be placed at some height. When they are placed at some height, they are going to be delivering better communication, right? So after that, moving to the sky waves. The sky waves are the waves that are reflected by the ionosphere. Okay, so it is also the layer of layer above the earth's surface that is called as the ionosphere. So the signal will be reflected by the ionosphere once it is transmitted from the transmitting antenna, and then it reaches the receiver. Such waves are called as what? The sky waves, right? Now moving with the wave propagation. Moving with the wave propagation. So now we see the wave propagation. So what is basically propagation? First we study what is propagation. Propagation means when the signal is transferred from the transmitter to the receiver, the path the signal is going to go through, the journey of the signal, otherwise the wave from the transmitter to receiver, is called as propagation. Okay, that means the signal is propagating. Okay, so what is the propagation? The signal or wave traveling from transmitter to receiver is called propagation. Okay, so the signal travels from the transmitter to receiver, and that itself is called as what? So the signal, the traveling of the signal from the source to the destination, the traveling of the signal from the transmitter to the receiver is called as what? The propagation. Okay. Depending on the paths, the waves follow. Depending on the paths, the waves follow to reach the receiver. Depending on the paths, the wave follow to reach the receiver. The different types of propagation is classified. Different type of propagation is classified. Okay, clear? So, propagation means the signal or the wave traveling from the transmitter to receiver is called as propagation. Otherwise, the signal is said to be propagating. So, depending on the path the wave is going to follow, okay, to reach the receiver, the different types of propagation is classified. So, the different types of propagation are ground wave propagation, space wave propagation, and skyway propagation. Okay, ground wave propagation, space wave propagation, and skyway propagation. Okay. So, what is propagation? The classification of types of propagation. Okay, ground wave propagation, space wave propagation, also called as line of sight loss, line of sight propagation, or tropospheric propagation. It is also called as tropospheric propagation. Okay. It is also called as line of sight propagation or tropospheric propagation. The skyway propagation is also called as ionospheric propagation. Otherwise, will be ionosphere propagation. Okay. So, types of propagation, otherwise the types of wave propagation. This is a 3-mark question asked, otherwise 2-mark question asked. Mention the different types of wave propagation. So, different types of wave propagation are ground wave propagation, space wave propagation, and skyway propagation. Whereas the different types of waves are ground reflected wave, space wave, and skyway. But types of propagation are four types. Sorry, three types. Four types of waves, but three types of propagation. Okay, ground wave propagation, space wave propagation. It is also called as surface wave propagation. Ground waves are also called as what? Surface wave propagation. Also called as surface wave propagation. Okay. So, so we have already studied about the ground waves, space waves, and sky waves in the previous class. The signals that follow the path as the surface of the earth are called as ground waves, and the propagation taking place with the ground waves is called as ground wave propagation. Okay, when the signal is transferred from the transmitter, it follows the path of the surface of the earth. Otherwise, the signal travels through the surface of the earth. Such propagation is called as what? Ground wave propagation. Space wave propagation, I have told you, line of sight is required there. That means the two transmitters has to be placed face to face. They must listen to each other. It is better to always place the antennas at some height. Okay. So about this space wave propagation, otherwise the line of sight propagation or tropospheric propagation, it is required for the propagation to take place to maintain the two transmitting antenna, the transmitting and the receiving antenna facing one another. They should be placed opposite to one another. There should be no obstacles in between. Nothing should be there in between their path. Right? Skyway propagation. What about skyway propagation? The type of propagation that is taking place due to the skyways. That means when the signal is transmitted from the transmitter, once by reflecting by the ionosphere, the signal reaches the receiver. Such type of propagation is called as what? Skyway propagation. Okay. So we will study the ground wave propagation. From 30 kilohertz to 3 megahertz. Okay, 30 kilohertz to 3 megahertz. So these ground wave propagation are suitable for low frequencies. Okay, and the signal transmitted follows the surface of the earth. In the previous class, we have also seen how the waves propagate. There we have seen that the signal transmitted is going to be absorbed by the earth. Why it is absorbed by the earth? Because the earth is having its own resistance. Okay, and this absorption of the signals by the earth. Okay, absorption of waves by Earth, it increases with increasing frequency. It increases with increasing frequency. Okay, so this is going to increase with the increasing frequency, right? So ground wave propagation suit is not suitable for high frequencies. Okay, and around some 500 kilohertz, it gives the best possible communication. Okay. So about the ground wave propagation, it is suitable between the frequencies 30 kilohertz to 3 megahertz. Okay. The operating frequency range, the ground waves are all the waves between. Ground waves are the waves between are the waves having frequency 30 kilohertz to 3 megahertz. Okay, so the frequency range for the ground waves lies between 30 kilohertz to 3 megahertz. Okay, all the frequencies above the 3 megahertz, the frequencies above the 3 megahertz will be completely absorbed by the earth. Earth will simply absorb. So for the higher frequencies, the earth is going to be simply absorb all the signals. So the signals has to be considered near about 500 kilohertz for better or the best communication up to some distance. Okay. Again, distance is the restrictions in the ground wave propagation. Why? Because in the previous class also I have discussed this point that as the signal moves away, yes, in previous class I have told you this example, the signal keeps on reducing. Okay, signal keeps on reducing as it is moving away from the transmitting antenna, right? So as the distance is increasing, as the distance keeps on increasing, the signal just absorbs, the earth just absorbs the waves and the strength of the signal keeps on degrading. Strength of the waves, otherwise the signal keeps on degrading or reducing, right? So this is one of the restrictions for the ground waves. So the ground wave propagation we can use between the frequency range of 30 kilohertz to 3 megahertz, 30 kilohertz to 3 megahertz, and absorption of the waves by the earth increases with increase in the frequency. So all the waves above the 3 megahertz will be simply absorbed completely by the earth and nothing reaches the receiver. Okay, so using the ground wave propagation, if we use any signal having a frequency greater than 3 megahertz, that signal will be completely absorbed by the earth and it will never reach the receiver from the transmitter. Right, so this is about the ground wave propagation. Now about the space wave propagation. So the space wave propagation law. So the space wave propagation is also called as line of sight propagation or the tropospheric propagation, right? So what is this troposphere? Okay, so this is the immediate layer above the Earth's surface where most of the moisture, wind, dust appears. Okay, resides here where exists all the dust, wind, and water is present in the troposphere. The layer of Earth atmosphere is called as troposphere, right? The layer above the Earth's surface where most of the dust, moisture, that means the water content, wind exist. Okay, that is called as troposphere. Now the tropospheric propagation, otherwise the space wave propagation, otherwise the line of sight propagation is there is an antenna placed here and another antenna placed here, and normally in the tropospheric propagation the antennas are placed facing one another, plus they has to be placed some at some certain height so that a direct link is established between the transmitter and the receiver. Okay, and these operate with 30 megahertz to 300 megahertz. So the tropospheric propagation requires a very high frequency. Okay, that is also another aspect of the tropospheric, otherwise the line of sight or the space wave propagation. So this portion is called as the space. So the signal is traveling through the free space from the transmitter to the receiver without getting any obstacles, without being reflected anywhere. Okay, so such type of communication, otherwise the propagation is called as what? The space wave propagation, otherwise the line of sight or the tropospheric propagation. Right? So what are the requirements? We have already discussed it. That is, line of sight has to be there, and very high frequencies 30 megahertz to 300 megahertz must be taken. The signal must have that frequency for establishing a space wave propagation. Right? Next, skyway propagation. Skyway propagation, ionosphere propagation. Skyway propagation or ionosphere propagation. So the type of propagation that takes place from the transmitter to the receiver by being reflected by the ionosphere. Okay, so what we require here is the ionosphere. So the signal transmitted hits the ionosphere, reflected back and reaches the receiver. Okay, transmitter, receiver. Okay, so the skyway propagation, otherwise the ionosphere propagation is the type of propagation. It is the type of propagation where the signal emitted, otherwise transmitted from the transmitter, hits the ionosphere, reflects by the ionosphere, and then reaches the receiver. This type of signal is called skywave, and the propagation that uses skywaves for the propagation are called as the skywave propagation. Right? So here, ionosphere comes in picture. What is this ionosphere? Ionosphere is the layer above the Earth's surface. After the troposphere and stratosphere, there is ionosphere. Okay, that is ionized due to the rays, UV rays from the sun. Okay, it is ionized. That is reflecting the certain frequencies and absorbing certain frequencies. Okay, so depending on the different frequencies, very high frequencies or medium to high frequencies, some layers reflect them and some layers simply absorb them. Here, this is about the skywave propagation. Now we will see detail about the layers of ionosphere. The layers of ionosphere. Okay. This is troposphere. Stratosphere. Then starts the D layer, E layer, and F layer. Sometimes read as F1 and F2. Okay. So the D layer, it is between 50 to 90 kilometers away from the Earth by 50 kilometers and extended up to 90 kilometers. E layer 90 to 140 kilometers. Okay, the next layer to the D layer is the E layer, that is spread from 90 kilometers to 140. Next, the F1 layer 140 to 240 kilometers. 140 to 240, and finally 240 to 400 kilometers. So these are the different layers of ionosphere. Layers of ionosphere, right? So this is a very important topic that is very oftenly asked in the exams for the 5 marks to 2 marks. 2 marks to 3 marks, a total of 5 marks from this chapter. Where if asked for 2 marks, they will just ask you draw the ionosphere, layers of ionosphere with approximate range in terms of kilometers. Okay. Otherwise, they can ask you to write a note on D layer, E layer, and F layers of ionosphere. Okay, clear? So here, this E layer is also called as Canale heaviside layer. So this is a very oftenly asked question. What is the other name for E layer? So you will write Canale heaviside layer. Otherwise, which layer of the ionosphere is also called as Canale heaviside layer? You have to write E layer. Okay, the F layer together are called as Appleton layer. Appleton layer. Okay. Why it is F1 and F2? Why it is not only F layer and then G layer? That is because the F layer unites during the night. Okay. Due to the rays reaches the ionosphere during the daytime because of the ionization due to the rays of sun, the layers extend, spread, and they will form F1 and F2 layer, right? So now we will study detail about each layer. The D layer, it is spread between 50 to 90 kilometers, okay, and it contributes in the wave propagation, the ionospheric wave propagation, otherwise the skyway propagation during daytime. Reflects otherwise D layer exists. D layer exists only in day. It this appears during night. It disappears during night. So this D layer exists only during the daytime because in the day the in the daytime the rays of the sun reach the ionosphere, and because of that ionization takes place and this layer D layer exists. But during the night time, as there will be no rays reaching to the ionosphere, okay, it is only with respect to the different regions in the earth. Okay, if we speak with respect to the India, then whenever there is daytime, we can take the reflection, otherwise we can take the propagation through D layer, but it is not useful during the night in India. Okay, maybe in other regions of the other areas of the earth there might be day and their D layer is existing, but it is with respect to the different geographical areas, right? So overall about the D layer, it says that it exists only during the day and it disappears during the night. So the propagation can take place only during the daytime with the D layer. Okay. E layer. Here the range is very important, 90 to 140 kilometers. So the E layer, here about the E layer, what we have to see is, even though it appears in day and night, it appears in both the times, but its strength is very weak during the night. Okay, because the absence of sun rays, the layer even though appears in both day and night time, but its effect during night time is very weak. Appears for day and night, but its is less effective during night. Okay. Here. Next the F layer. Next about the F layer. So there also I have written, it is also called as cannellate heaviside layer. Cannellate heaviside layer. Next about the F layer. Okay. So about the F layer during day time they appear as two different layers as F1 and F2, where F1 is spread over 140 to 240 kilometers and F2 is spread over 240 to 400 kilometers. Okay, but during the night time they will appear as a single layer of ionosphere. During the night time they appear as a single layer of ionosphere, right? So this is about the different layers, D layer, E layer, F1, F2. So the overall ionosphere is spread over 50 kilometers to 400 kilometers. The spread over overall ionosphere is spread over 50 kilometers to 400 kilometers, right? Now, radio horizon and optical horizon. The horizons, radio horizon and optical horizon. Radio and optical horizon. Okay. Again, we can show it with the help of a figure. This is the earth. An antenna is placed here. Okay. Here. This is the antenna. Okay. Now, the signal transmitted, the radio horizon, the signal transmitted can reach up to this point. Okay, this portion is called as what? Radio horizon. Okay, but the line of sight, otherwise the eyes that can observe, otherwise see up to this point. Okay, this much is called as optical. This is called as what? Optical horizon. Okay. So from the figure you can get an idea the amount of distance the radio waves can cover. The amount of distance the radio wave can travel is called as what? Radio horizon. Whereas the distance that maximum is visible to the naked eyes is called as what? Optical horizon. Okay. This is just about the definition. Radio horizon and optical horizon. So what is radio horizon? The maximum distance the radio wave can travel is radio horizon. Whereas, what is optical horizon? Optical horizon is the maximum distance the naked eye can see. Okay. Is optical horizon. Okay, and obviously the radial horizon is greater than the optical horizon. Okay, these are the two important definitions in the horizon of propagation. Radio horizon is the maximum distance a radio wave can reach is called as radio horizon, and the maximum distance a radio wave can reach is called as radio horizon, and the maximum distance the naked eye can see is called as the optical horizon. And obviously radio horizon is having greater value compared to optical horizon. Now few terminologies. Okay. First one, skip distance. Skip distance, skip zone, critical angle, critical frequency, Hawk transmission and fading. These are few important terminologies of the wave propagation, right? So skip distance. What is the skip distance? The distance between the transmitting antenna and the first receiving antenna. Okay, this is the transmitting antenna and this is the first receiving antenna, and between these two there will be no signal available. Okay, there is no propagation, none of the signals are available. Is called as this particular zone is called as dead zone, otherwise the skip zone. That is the next definition. So the distance between the transmitting and the first transmitting and the first receiving antenna is called as what? Skip distance. The maximum distance between the transmitting and the first receiving antenna is called as what? Skip distance. Okay. Next, skip zone. Skip zone. The next thing is skip zone. Skip zone is the region where no radio waves are present. No radio waves exist or are present. No radio waves present or exist. Is called as what? Skip zone or dead zone. Okay. It is called as skip zone or dead zone, where none of the signals are available. None of the EM waves are available, and that is exactly between the first and the transmitting antenna and the first receiving antenna on the earth. Next, critical angle. Critical angle. The maximum vertical angle. The maximum vertical angle. The maximum vertical angle above which the wave never received back by the earth. Okay. So if the signal is, this is the ionosphere, it is sending a signal. Okay, it is the maximum angle, vertical angle in which it can send. Okay, but beyond that it will simply be lost in the ionosphere. Okay, the maximum vertical angle of propagation, obviously, angle of propagation above which the signal, otherwise the wave, never returns back to the received back by the earth or never return back to the earth. Simple rules. Okay, never returns back to the earth. Next, critical frequency. It is also the same, but in terms of the frequency. Okay, so the maximum value of frequency of propagation above which the wave never returns back to the earth. Simple. Okay, so critical frequency is the maximum frequency of propagation beyond which or above which the wave never returns back to the earth. The wave never returns back to the earth. Okay. The signal never returns back to the earth if the value of frequency is taken greater than the critical frequency. If the angle is taken greater than the critical angle, then the wave is simply lost in the layers of ionosphere. It will be lost in the space. Above the critical frequency, signal will be lost in the space. Skip distance, maximum distance between the transmitting and the first receiving antenna. Okay, within that skip distance, that particular range, there will be no electromagnetic waves, otherwise the radio waves are present. Okay. Skip zone is the region where no radio waves are present or exist. It is also called as what? Dead zone. So these are the important terms of the wave propagation. Next, another term called as Hawk transmission. Hawk transmission and fading. The last terms. The last two important concepts in the wave propagation, right? So that is what Hawk transmission. Okay, so in the Hawk transmission again there are two types of single Hawk transmission and multiple Hawk transmission. Single Hawk transmission and multiple Hawk transmission. Here there is one antenna, here there is one antenna, this is ionosphere. This sends a signal, it reflects by the ionosphere and reaches the receiver. Okay, this is one example. This is transmitter, this is receiver, and this type of transmission is called as single Hawk transmission. This type of transmission is called as what? Single Hawk transmission. Okay. But we take another example where there is another small repeater or receiver placed here. The signal travels and reflected by the ionosphere. Again, it is reflected by the earth, bounces again and reaches the receiver. Okay. This type of transmission is called as what? Multiple Hawk transmission. This type of transmission is called as what? Multiple Hawk transmission. So the Hawk transmission basically means that the signal is reaching the receiver by being reflected by the ionosphere. Such type of transmission is called as what? Just a Hawk transmission. Okay? It is taking a hop, otherwise a jump, right? Otherwise a bounce, we can say. So in that Hawk transmission is further classified as single Hawk transmission and multiple Hawk transmission. In single Hawk transmission, the signal is reflected only once by the ionosphere. But in multiple Hawk transmission, the signal is reflected by the ionosphere multiple times. Here I have taken an example of two Hawks, otherwise two type reflections. This can take multiple reflections also. And this type of transmission is done for large, otherwise long distance communication. Right? So what is single Hawk transmission? The signal, otherwise the wave, travels from transmitter to receiver by being reflected by the ionosphere, only once. So it is reflected by the ionosphere only once while being transmitted from the transmitter to receiver. Next, multi-hop transmission. What is multi-hop transmission? The wave travels from transmitter to receiver by being reflected by the ionosphere more than one time, more than once. Okay, so it is reflected by the ionosphere more than once. Such type of transmission is called as what? Multi-hop transmission. Now the last terminology is called as fading. Okay, fading means the sudden, otherwise the degradation, otherwise the decrease, degradation or decrease in the signal strength, in the signal strength. Okay, so fading is the degradation or decrease in the signal strength during the propagation. During the propagation. Okay, so during the propagation, what happens? The signal keeps on degrading, otherwise the strength of the signal keeps on decreasing. This type of result, otherwise this type of decrease or degradation observed in the signal strength is called as what? Fading. Okay, so to avoid fading, we can use repeaters, otherwise we can go for multiple hop transmission, because the signal that is being degraded can be recovered, otherwise boosted again by the repeater section here. Okay, so this is all about the chapter wireless communication, where we have studied starting from the block diagram. We covered the EM waves, the electromagnetic waves, and moving to the types of waves, that is ground wave, ground reflected wave, space wave, and sky wave. And then we move to the types of propagation, where we have seen that there are three types of wave propagation, that is ground wave propagation, space wave propagation, and sky wave propagation. We have seen all about the ground waves, ground reflected waves, and the space waves and the sky waves, where ground reflected waves travel through the surface of the earth, where ground reflected waves are reflected once by the earth surface. Space wave requires the line of sight, and it is a direct link between the receiver and the transmitter. Sky wave propagation occurs when the propagation takes place by being reflected by the ionosphere. In that also we study hop transmission, where we have studied single hop and multiple hop transmission. Single hop transmission, the signal is reflected only once by the ionosphere. Single hop transmission. Reflected more than once, multiple hop transmission. Fading, degradation, otherwise the decrease in the signal strength during the propagation is called as what? Fading. Apart from that, we have seen skip zone, skip distance, critical angle, critical frequency. Skip zone, otherwise the skip distance. Skip distance is the maximum distance between the transmitting antenna and the first receiving antenna. Whereas a skip zone is the region where there are no radio waves present at all. Right. Apart from that, we have also studied the different layers of ionosphere: D layer, E layer, F layer, where E layer is also called as canally heaviside layer, F layer is called as Appleton layer. About the D layer, it is spread over 50 to 90 kilometers. E layer spread over 90 to 140 kilometers. F1 layer 140 to 240 and 240 to 400 is the F2 layer, where F1 and F2 combined and represented as a single layer during the night. The D layer does not exist during the night time, right? So these all about the layers of ionosphere also we have studied. So this is all about this chapter, wireless communication. Next we will move to the chapter 8, that is modulation and demodulation. So this is all about today's class, students. Thank you.